Hello, my name is Mike Britton. I'm an advanced design and manufacturing specialist here with GoEngineer, and today we're going to talk about advanced design using patterning in desktop SOLIDWORks and our latest 3D experience tools. Before we get too far in, don't forget to like and subscribe to this channel for more guides and product demos from us here at GoEngineer. Let's talk about advanced design. If you've taken our SOLIDWORks Advanced Parts class, you'll recall that we cover a variety of topics like lofts, sweeps, and boundary bosses. Instead of thinking about particular tools, I like to think about advanced design in the context of our resulting geometry. Advanced geometry substantially utilizes non-planar, non-cylindrical, and non-conical surfaces. Those geometries are the biggest advantages all those lofts, sweeps, and boundary bosses give us. This particular example is a bicycle handlebar, and I created this using a lofted boss. If I hide the body and show the sketches that were used to create this part, we can see that I made this using two elliptical curves as the profiles, one straight guide curve, and one spline guide curve. If you look closely at the yellow porcupine bars coming off from the spline, you can see that I've taken care to construct this with consistent curve continuity. This single feature provides the basis for further design that we'll do here in SOLIDWORks. If you're on this channel, you know that SOLIDWORks is the premier mechanical design software. Designing and testing mechanical systems in SOLIDWORks is incredibly efficient, so let's dive into the product design side. Using my Food Network style magic oven, we can see that I have some design variants ready to go. The first we'll take a look at is the hex indented grip configuration. We can see in this variant that I have an indentation in the grip and a honeycomb pattern filling that indentation. Looking at the feature manager tree, I used one of our advanced patterning techniques called fill pattern. Fill pattern is a fantastic tool for creating repeating geometry like this in SOLIDWORks. Creating perforations can be a pain, and this excels at it. One of the greatest parts about the fill pattern feature is that it doesn't even require a base feature or sketch. You can just create a polygonal profile within the feature's property manager as shown here. We can see that I have a fairly short feature manager tree to achieve this kind of geometry. We can see in the feature manager tree that I used a little bit of surface modeling to create this indentation that provides the boundary for this fill pattern, and that after our fill pattern feature, I used a mirror in order to recreate the fill pattern on the other side, and I used some more surface modeling afterwards in order to create a non-planar bottom of these honeycomb holes. That way, I have matching surface topology from the outermost surface, the bottom of the indentation, and the bottom of my honeycomb holes. That's one example of our advanced patterning tools inside of SOLIDWORks. Let's take a look at another. I'm going to come to my configuration manager. I'm going to activate my indented grip configuration. This is another design variant which uses the same indentation as the hex grip pattern. You'll note though that I only used a linear pattern to create this grip, and this also maintains our continuous surfacing from the rest of our handlebar. We can see that the linear pattern references the Boss Extrude 1 feature. Let's examine the sketch for Boss Extrude 1, and you'll note that there are only two dimensions, one for the radius of the slot, and the other for the offset of that slot profile from this offset boundary here. The rest of the constraints which determine the geometry of this profile are geometrically constrained rather than dimensionally constrained. This means, as one might expect, if I increase the offset here, and the bounds of this slot are designed to follow this construction geometry, that when I confirm that, we can see that the slot geometry changes. Let's see how this pays off for our linear pattern feature. We can see that for my pattern direction, I used a dimension from the seed features sketch. This is a necessary component for this trick to work. We can see that for my features and faces, I am using the boss extrude that created the extruded slot profile, but not all of these are the same. Under the options section, by taking the Vary Sketch option, we can see that as SOLIDWORKS recreated this feature, it increased the length of this slot profile just like we saw when we edited that dimension inside of the sketch. By using a dimension from that sketch as my patterning direction, and by ticking the Vary Sketch option, SOLIDWORKS is able to use those geometric constraints in order to vary each resulting pattern feature. Let's take a look at another configuration I have here in SOLIDWORKS. This kind of pattern represents the upper bounds of what are possible within SOLIDWORKS. These are conformal helical patterns about a largely curvature continuous surface. Let's take a look at how these were made. To create these curves, I created helices using a surface sweep. By using a single line as a profile, I am able to specify the number of twists along the sweep path. In this case, half of one complete revolution. I recreated this in the counterclockwise direction as well by simply tweaking one feature. I then used a circular pattern to create multiple helices, almost like a multi-start thread for both the clockwise and counterclockwise helical profiles. I was then able to use the intersection curve command in order to generate 24 helical intersections between those helical surfaces and the solid that I started with. Using the intersection curve command to create those conformal helical paths, I then created sweep profiles in order to create swept cuts inside of this handlebar. Because each of these helices are conformal to this irregular solid, I had to manually create each of these 24 swept cuts individually. I did say, though, that we are near the upper bound of what SOLIDWORKS can do. If I turn my curvature evaluation on again, we can see that I'm maintaining curvature. However, there is some marring on these bottom surfaces. These are not possible to manufacture in any reasonable way. So I then had to make some adjustments. If I turn off my evaluation, come over to my configuration tab, we will activate my last configuration. In that prior configuration, those cuts made the individual upper surfaces that I wanted to, but we needed to do some tweaking for manufacturability. So what I did was I offset each of those surfaces and I copied my original solid body here. And what I was able to do was thicken each of those surfaces into the part. However, because each surface has its own normal, I had to do that for every single one of these surfaces. As you can see, there are quite a lot of thicken commands in order to achieve this. Thicken 144 is where this particular configuration ended, and if we look at the ends of each of these, we can see that some updates still need to be made for manufacturability. So, where do we go from here? What is the next level up for advanced patterning and design? Well, now we have a lot more answers to our design requirements than just desktop SOLIDWORKS. We have whole new suites of tools for increasingly advanced design thanks to the 3DEXPERIENCE platform. The rest of our design exploration is actually going to take place inside of the web browser instead of a dedicated desktop application. We're going to be taking a look at our SOLIDWORKS 3D Creator role, specifically the XDesign application, And we are later on going to take a look at our 3DEXPERIENCE CATIA 3D pattern shape creator role. I'm going to open up the bicycle handlebar part that I've created here in xDesign. And while we're here, I just want to clarify that SOLIDWORKS, the desktop application, is not the only SOLIDWORKS thing. There are lots of SOLIDWORKS branded roles on the 3DEXPERIENCE platform. Most of them are in the browser, so on top of our 3DEXPERIENCE desktop SOLIDWORKS applications, so where those are connected to the cloud, we also have things like SOLIDWORKS 3D Creator, the featured app for which is xDesign. We have 3D Sheet Metal Creator, also SOLIDWORKS branded. We have 3D Sculptor. So we are here in the browser, and I'm going to collapse this. We'll talk about that later, but I just want to talk about the Design Manager tree. This is very familiar to SOLIDWORKS users. It's a lot like our Feature Manager tree. We have our physical product, a 3DEXPERIENCE PLM aspect, same with the 3D shape, but then we also have our design features on top of our base reference planes. As you can see, this bicycle handlebar is also made from a single loft feature. If I hide my loft and show the sketches and curves that were used to create it, we can see a very similar story to what we did inside of SOLIDWORKS. So we have two elliptical profiles, we have a straight guide curve here, we have our spline guide curve here, constrained exactly the same way as we did in SOLIDWORKS. You may note, however, that there are two additional guide curves about the top and the bottom of this. These were used as additional constraints for this lofted solid. And this kind of indicates something that is going to become progressively more important throughout this video. The advanced patterning tools that I am going to demonstrate need to be done in a 3DEXPERIENCE product, not a desktop SOLIDWORKS product. In addition to the 3DEXPERIENCE X apps that are used to create, xDesign, xShape, xSheetMetal, things of that nature, we can also use this patterning workflow on parts designed in CATIA. So CATIA Mechanical Designer, for instance, parts will be usable inside of this workflow. Parts designed in desktop SOLIDWORKS will not maintain their associativity nor import completely correctly for this next segment. I'm going to change apps from 3D Creator's xDesign to the 3D Pattern Shape Creator's xGenerative design. We can see that this is CATIA branded. If you look in the top left corner, my logo went from SOLIDWORKS Red to CATIA Blue, and that I have been able to pull in my part that was designed inside of SOLIDWORKS. I'm going to come to my Tools tab down here on the Action bar. I'm going to come to my Lifecycle tab on the Action bar, and I am going to view my revisions. We can see that this is a native 3DEXPERIENCE PLM input. Similar to my SOLIDWORKS configurations, I have a handful of branches here that we are going to explore. So here we have our bicycle handlebar, and I am going to hide this feature here. I'm going to show some of my design sequences. I have activated another revision here, the quad grip bicycle handlebar, and we can see that I have a nice set of ordered and chunky grips for this bicycle handlebar. This is a kind of geometry that would be very, very difficult to achieve inside of SOLIDWORKS. And I kind of want to take you through how this type of geometry gets generated in the first place. First, why do we have our design features up here for xDesign, and why do we have our design sequence down here for xGenerative design? Well, if I activate the kind of preferred way to work in this application, that is called activating the graph view. And I'm going to, for the sake of presentation, put this in overlay mode so we can kind of see what we're working with on top of our part. So there's a lot happening here. There are a lot of kind of strings going from node to node. So let's talk about how this works. This is what is called a visual scripting interface, or a node-based graph editor. This is used a lot in product design software. This type of interface is also frequently used in advanced graphics and things like that. So this is new to us on the mechanical side, but there are some established components for it. The things that the node-based editor does really well is refer to every single state that has ever been created. Do you ever have a SOLIDWORKS project where you wish that you could kind of keep referencing these edges that have now been consumed later on in the process? Well, xGenerative design can do that, or xgen for short. xGenerative design is what is called a disordered modeling environment. In an ordered modeling environment, every new state or every new feature consumes the existing state of your part before it. So the disordered state allows you to reference that at any time. That's why I have so many of these different components hidden. For instance, if I showed this set of points, I could view that any time or this set of faces rather, I could view that again any time at any stage in the development of this product. We have some fundamentals covered, so let's take a look at kind of how we got here in broad strokes. More involved deep dives in xGenerative design are in the pipe, so keep an eye out if this type of tool seems exciting. The first thing that we need to do is, one, we start with our references, so it's just like every other 3D modeling software. We have X, Y, Y, Z, Z, X, and we have our origin. In this case, I have reference geometry. That is what I got out of xDesign. Over here in this folder, just like I create folders in my SOLIDWORKS feature tree, I can create folders inside of my graph editor. This is all designed to isolate that swoopy lofted surface there. So I wanted a solid to come out of xDesign. Well, here I just need to isolate the surface to work on. From here, I come down to this lower folder, and we can see some things that have been edited here. First, how did I get all of these faces here? Well, I used points to create them. I created UV curves, or UV intersections all along this surface, and they are spaced evenly for 15 in U and 15 in V axes. I then used those points to create a Voronoi pattern, and I did some offsets, created some boundary surfaces, filleted my corners, and eventually extruded these surfaces that came out of here. These last bits, the kind of adding everything together and publishing, are so that I can see this in my external geometry. One of the things that I really want to emphasize, though, I'll swap over to my 3D view in the overlay, is just how impressive some of these surface extrudes are. This surface draft feature here allows me to take all of these surfaces that were generated. So that took 225 of these fill surfaces and extruded them all normal to their faces. It extruded them 1.5 millimeters. I created a controller for that. and even gave them a draft angle of 10 degrees so that these can be molded more easily. All 225 of those faces were handled with a plumb by this software. I did not have to manually thicken 144 surfaces or anything of that nature. So we've seen a fairly well-ordered grid, but what if we wanted something a little bit more organic? Well, using almost exactly the same set of operators, I've been using the term features earlier because that's what we use in feature-based solid modeling. For this type of parametric generative design, we're using operators. Instead of using a UV sample, I used a randomized surface sample, but I used the same Voronoi curves and surface drafts and so on to generate this geometry here. This is much kind of scalier or stony looking and is similarly chunky. Now, we've taken a look at some of these variants. Is there any way to kind of refine these surfaces and get them maybe on a smaller segment? Well, I did create an indented variant. Now, I took great care to ensure that I could create these indentations in XDesign in exactly the same way as I did in SOLIDWORKS, just to show that these workflows are more or less one-to-one. Now, on our top side, we have some narrower, generally kind of features that we're getting from our Voronoi pattern. And from the bottom, we have another kind of stone or canyony, desert, scaly type of output there. And once again, this was done simply by having a more refined isolation segment of our surfaces. I was just able to manage the list of surfaces created in a different way for this. Again, in our deeper dives talking about XGen, we'll be covering some of these techniques, things like lists, what are our different boundary representation entities, things like that. I've done a fair amount of talking about how xGenerative design works. Let's cover how to do about it. Let's make a quick variant right here on our own. I am loading in a fresh revision of our part here, and we are going to take in from an early starting point how these types of things work. I have one of my earlier design sequences showing, so I'm just going to hide that folder, and I am going to just fire up my graph editor. Incorrect button there. Here we go. So I will turn these two off here. And even though we can't see it, I do happen to know in this revision that my isolated handle skin is showing. So if I were to show the set of operators here, we should be able to see what we're working with. So that is our base surface in there. It's invisible for the majority of this workflow, but I did want to indicate that it is actually working. The first thing that I'm going to do, and I'm just going to search for commands like I do in SOLIDWORKS, is I am going to get the triangulate operator. So we have this guy here, and as I click on this, I can hit my little question mark, and we can see the help menu pops up. It's super handy. I use it almost every single time. It is asking for a surface to triangulate and the length of sides of the triangle. So what I'm going to do first is pull out this length, and I'm going to rename it just like I would with SOLIDWORKS features, and I'm going to call this the triangle side length, and I'm going to set that at 5 millimeters. And now I'm just going to click and drag this node output from my handle skin onto my input for the triangulate. And now we can see in the background that I have a triangular grid of faces that maps to the surface that we are referencing. With my 2 operators set up so far, one really with an input. I'm going to do one more thing, and I'm going to left click this triangle side length. I'm going to hit this button here to make a controller out of it. That'll be more important a little bit later, but it is something that I do want to show. The next thing that I am going to do is get my center point operator out. And what the center point does is if I click up here, we can say that it's looking for any geometry input, and the output of that is the center point of that geometry. So this triangulate 1 is creating lots of triangular curves. So we have 1,326 triangular curves in fact. And I'm going to drag that to my center operator, and we can see that there is now a center point on each of these triangular curves. I now have to take these triangular curves and make some surfaces out of them. So I'm going to get my fill surface command, and it is looking for the outer bounds of a surface. So as I click and drag my triangulate command over, or the output from my triangulate command rather, we have gone from 1,326 curve outputs to 1,326 surface outputs. Note how those icons have changed. Surfaces here, curves here. I'm going to hide this triangulate node so we can kind of keep track of how we are going from there. The next thing that I'm going to do is generate a line. And if I just search for line, we can see that we have lots of line options here, but I am going to select the line point direction. So as it sounds from the name, as I just click on here, it wants a point to start from, a direction vector, and then we input the length. Start length is offset from your starting point, so I'm going to leave that for 0 here. And then the length of the line. And just like in SOLIDWORKS with our reverse direction arrow, we have an orientation switch here. So what I'm going to do is for my starting points, it defaults to the origin, as we can see down over here. I'm going to use actually all of these center points, all 1,326 of them, as my starting point. And the directional support it's looking for is defaulting to the XY plane down here. And I am instead going to say I want these to go opposite of the surfaces they are mapped to. So now we can see that each of these lines is getting extruded perpendicular to the normal of that surface, or perpendicular to that surface. And the overall length of these lines, I'm actually going to make you a controller also, bring it way over here. I'm going to call this the diamond height parameter, and I'm going to set this to 3 millimeters and make a controller out of this also. This is going to come into play shortly. So, okay, we have a bunch of lines. We have a bunch of triangular surfaces. The next thing that I am going to do is find the end point of all of these lines. So I'm going to say I want my point on curve by ratio. So instead of having to know how long all these curves are, I can just grab each of these line curves. The default ratio, if I click in here, is 0.5. I'm just going to set that to 1. Oh, not 13, just 1. And now I have an endpoint on all of these points. So let's hide some of our earlier work here and just kind of see what we're working with. So we have our endpoints all out here, and we have our nice shiny triangular surface there. The next thing I'm going to do is use the extrude to point command. So I went through all that hassle of creating those endpoints out there. And what I'm going to do now, if I left click inside of extrude to point, it's looking for our base profiles, and it is looking for the target point to which we are going to extrude all of those. Well, my base profiles are all going to be from the triangulate command back there. So once again, disordered, I can reach way back out here and put it out to something new. And the end point of all of these extrusions is going to be those endpoints that I just made. If I hide those, we can see that we have this wonderful spiky surface that we've created. Once again, we have created another 1,326 surface bodies. So what I'm going to do is use my close surface command, and that will take this from 1,326 surface bodies to 1,326 closed volumes. Look at how that icon has changed. So we have volumes here, surfaces here, and curves all the way over here. So we can work with all of that. And if I wanted to see this in xDesign, for instance, I would use my publish operator here. And that means that this would be visible for future purposes. So we've created something that would otherwise be more or less totally impossible inside of SOLIDWORKS. So we have our diamond grip setup. I'm going to put all of these into a folder. All right, and we'll call this region the diamond grip setup. I will also organize those inputs, and I'm going to change the color on this to a nice robin's egg blue. I'll save my part, and I am going to close out of my graph editor. This geometry is published, so we are good to go there. And I'm going to click on a fresh tab inside of my tree, the experiment tab. We can do some experiments on my earlier ones, but these controllers are paying off because I no longer have to work with the graph editor to change anything. So I'm going to create a design variant of where we're at here. And my 5mm diamond sides are really tetrahedra, maybe, instead of diamonds. But now I'm going to change my side length from 5mm. Let's say we get our customer feedback that, you know, this is too sharp. Put something like a 10mm side to a triangle on there, and now we get something really big and chunky. Or perhaps the 5mm size was fine, but they were too tall, so they want to decrease the size there for our diamond height, and we can let that rebuild. There we go. So maybe that's a little too much, or maybe they only want 1mm output there. And once again, this is all completely real time. I am not doing any kind of editing magic over it. And we can see that we have our fine pattern here. I like this. I'm going to create a fresh design variant. And I can save this. I have my part saved here. And as I come back to my tree, I'll change apps back to my xDesign. There we go. And with the transition back to xDesign, a couple of competing geometries published there, but there we go. Now we have our part here ready to be added onto our existing geometry or to be further refined for manufacturability. If the final destination of your part that you have designed in xGenerative design is going back out to SOLIDWORKS, there's an easy workflow to do that. We can just hit this little tab down here at the bottom where our save icon normally is. We can choose the export option here, and we can choose a file on disk, and the file format should be SLD-XML. This is a special compatibility file type to go between the browser-based roles on the 3DEXPERIENCE platform and desktop SOLIDWORKS. Much like 3D Interconnect, there is one-way associativity between the design in the browser apps and SOLIDWORKS desktop. But if we just hit export here, then we'll swing back over to SOLIDWORKS and check it out. We're back over at SOLIDWORKS, and just on the main page or from File Open, we can go ahead and select the same thing we normally do, and we'll just read it in like a regular file. And there we have it. We're in Desktop SOLIDWORKS. We have our 3D interconnect type feature here, and we can see that it pulled in all the bodies that we made for our publication node on this particular part. We can add this into our assemblies, or we can do whatever other validation we want, or get cracking on mold design like we do. So it's really rewarding to see the back and forth that we have available between the browser and desktop SOLIDWORKS, and that we get to leverage all of these incredible design, engineering, and manufacturing technologies together. Thank you again so much for your time and learning about this new tool from our 3DEXPERIENCE suite of options. I am so thrilled by all the design possibilities that 3DEXPERIENCE 3D Pattern Shape Creator opens up for me, and I can't wait to see what you accomplish with it as well. Keep an eye out for more of our new design tools and videos about them on the GoEngineer YouTube channel, and I can't wait to see you in the next one. Thanks again, take care, and have a great day.